Hello children. Hello children, how are you? I hope you are all doing well at homes. Stay safe. Okay, stay at home. So today I am continuing the next part of your lesson. Okay, already you have learned the lesson acid bases, isn't it? You have learned previously what is an acid, what is a base, what are the indicators, which gas is liberated when acid combine with the metals. These things you have learned, isn't it? Now you are going to learn about something else, neutralization. What is neutralization? See here, so we learn about when acid neutralization combine with a base. What is this it neutral? Will forms, you know about acid, you know about and base. Water. What so is this neutral? Means acid, it is neither an acid combined with nor a base. Okay, these neutral solutions does not have any effect that on the we call them indicators. The indicators does not show or no effect. You will learn something about on the indicators about let this neutralization. See what is this neutralization or neutral solutions in depth. Okay, let us learn one by one point. First, the acids and bases will have different effects on the indicators, isn't it? When you take the methyl orange or phenolphthalein, these indicators will behave in different ways with acids and bases by changing its colors, isn't it? Like that, when mixing, how can the neutral solution forms? By mixing an acid and a base, then it becomes neutral. So how the neutral solutions are formed? They are formed by mixing an acid and a base. Okay, that means it is neither an acid nor a base completely. It is neutral in nature. Okay, so like that, we'll do with one activity also. Okay, what is it? Let us see. When you take an acid and a base, mix it in equal concentrations, then they give a neutral solution. How it behaves, let us see with an activity. Okay, children? Oh, this activity we have to do now. Okay, are you interested in doing the activities? Let us see a video and we will do in the classroom also, isn't okay? So here, if you observe, there is a test tube holder, and hydrochloric acid, and the filler. Okay, first what you have to do, take a test tube. Then normally in the laboratory you have to first clean the test tube very well. Okay, then only you have to use the test tube. This test tube, okay, clean it well, then take the hydrochloric acid. So what is an hydrochloric acid? Is it an acid or a base? It is easy to answer, isn't it? The name itself will tell you that it is a acid. It is an inorganic acid which is very dangerous. As I told you in the previous class, inorganic acids and organic acids. Inorganic acids are used in the laboratory and organic acids are present in our fruits, isn't it? Okay, so here we take this hydrochloric acid. You should be very careful in handling the hydrochloric acid. So what you will continue the activity by taking this hydrochloric acid. So take this hydrochloric acid into a filler and add 10 ml of hydrochloric acid into the test tube. So while adding the acid, we should be very careful. Okay, we should add the hydrochloric acid drop by drop. So what we have to do? We have to add the hydrochloric acid into the test tube by drop. Okay, how much we have taken? We have taken how much? 10 ml. Good. 10 ml you have to take in the test tube. So after taking the hydrochloric acid, what is present in the test tube? Hydrochloric acid. Okay. Now take an indicator, a synthetic indicator such as the phenolphthalein. Okay. This indicator again take with a filler and take the phenolphthalein and slowly add the indicator into an acid, that is into the test tube. Okay, so what you have to do now? Take the indicator and add into the test tube. See what will happen. Let us see. So after adding this indicator, what you will observe is there is no change in the color. First of all, what will be the color? First of all, the color will remains the same, and you will observe there is no change in the color. Let us observe the color. The color changed or not? No, isn't it? So the observe the color, then what you will get? Or you will observe that the color is colorless. Understand? So this phenomena already you have learned in the previous classes by the teacher, isn't it? Okay. When phenolphthalein is added into the acid, there is no change in the color. Okay, the color is colorless. Now, what is our aim? We have to conduct an experiment on neutralization, isn't it? Then we have to take a base. Okay, if you take the sodium hydroxide is also called caustic soda. What it is called? Caustic soda. Sodium hydroxide is a strong base. Okay, as an acid is dangerous, bases are also dangerous when strong. Okay, strong sodium hydroxide is also very dangerous to the skin, so you have to handle very carefully. So you take this sodium hydroxide, okay, and add this sodium hydroxide into the test tube. Already what is there in the test tube? Already 10 ml of hydrochloric acid is present, isn't it? So here what you are adding now? You are adding sodium hydroxide. If you observe, the formula is NaOH. Okay, NaOH is the formula for sodium hydroxide. Add this sodium hydroxide dropwise into the test tube. So what you are doing now? You are taking the sodium hydroxide from the dropper and adding slowly drop by drop into the test tube. Okay, then again we have to observe the color. What we have to do? We have to observe the color. Okay, it changes to which color? Yes, pink. It changes to pink color. When you add drop by drop, slowly the color will changes to pink color. Okay. So here already you learned that when base phenolphthalein turns into pink, but initially acid is present, na? Then you add the base, there is a reaction taking place between the acid and a base. It becomes neutral. Then you add more base, then only it will convert into pink color. So what color will you observe? Which color will you observe now? It is pink color. Then that means here its basic content is more and acidic content will be less. In terms of concentration, acidic concentration is less and basic concentration is more. Okay. Now you can do this as a magic also. So here which content is more? Basic content is more. That's why the color is pink in color. So you can do as a magic if you observe this again. So here if you add more base, is there any change in the color? Just imagine, is there any change in the color if you add more base? No. Okay, if you add more base or more sodium hydroxide drop by drop, you observe the color. What the color? It again pink color only. There is no change in the color. Then let us take this hydrochloric acid again, okay, and add slowly drop by drop into the test tube. What is the color of the test tube? It is in the pink color. Now what you are doing? You are adding slowly the hydrochloric acid drop by drop. Again you have to observe the color. Okay, slowly the acid combine with the base and forms a neutral solution. And if you add more acid, then what you will observe? What you will observe? The color is changes again into colorless, because phenolphthalein acid acid to the phenolphthalein gives colorless, isn't it? So here again slowly the pink changes to colorless, and again if you add more base it becomes pink. Like that you can do the magic of colors. So now we will go for a new one, that is organic manure. So this organic manure is very useful for the fertility of the land. So there is a relation between fertile lands and organic manure. See how the organic manure is prepared. Do you know? It is prepared from the waste or excreta of the animals and human excreta and vegetable matter. What is this vegetable matter? Vegetable matter is nothing but the peels of the vegetables, or in the kitchen while your mother is cooking the food, she will take the vegetables and cut all those peels of the vegetables, isn't it? Those wastage from the vegetables or the spoilage of the vegetables, they will collect at one place and you can make an manure with the help of the soil. Okay, it will help the soil. Okay, why we should use the manure? Because do you know, while using the fertilizers, okay, normally the farmers will use the fertilizers, chemical fertilizers, to increase the production. Okay, so they are also chemicals. They will spoil the land or the farming land. It will spoil. How? When there is a rain, the water will mix up with the chemicals and those will go into the soil and spoils the soil. That means it may increase the acidity of the soil or it may increase the basicity of the soil. So better we go for the natural organic manure is becoming a necessity nowadays, because it is fertilizer less, that means chemical less. These are all very useful in the soil. Okay, it will increase the fertility of the soil, then automatically it will be very useful and no chemical. Understand? Good. Now we'll go for the salts. So how the salt is formed? If an acid is added to a base, a salt and water is formed. Okay, do you think salt is a neutral? Yes, salt solutions are generally, they are neutral solutions. That means don't think that all the neutral salt solutions are salts. All the neutral solutions are not salts, but salt solutions are neutral. So let us see how what it is. What is the difference? That means when you take the sugar solution, okay, your mother will prepare sugar solution for you, isn't it? Sugar solution is neutral, but it is not a salt solution. Okay, then what is that salts? We will learn now. Okay, now let us take the salts. Okay, how the salt is prepared already you have learned. When acid is mixed with base, a chemical reaction takes place and salt is formed. For example, okay, in the activity, what we have done there, HCl is added to the sodium hydroxide to form a salt, sodium chloride, NaCl, and water is formed. So okay, if you see the copper sulfate, what is the color of copper sulfate? Copper sulfate is a salt. The color of copper sulfate is blue in color. It is a salt. The sodium carbonate, it is also a salt, white color salt. Nickel sulfate is a dark blue color salt. Iron sulfate is green in color. Okay, magnesium sulfate, it is white crystals or powder. Okay, cobalt nitrate is brown in color like this. These are all salts. Okay, but they are different salts. Salt is only common salt is sodium chloride, which you are using in the kitchen. This is called common salt, and these are also salts, but chemical salts with different chemical names. Copper sulfate, iron sulfate, sodium carbonate, nickel sulfate, magnesium sulfate, and cobalt nitrate. Do you think only these six? No, thousands of salts are there. Okay, let us learn about their properties. Okay, how it affects the litmus paper. We will got it out. Okay, some of the salts, okay, are not pure neutral. Some of them are affects the red litmus and also blue litmus. Let us see. Take the copper sulfate. What is the color of copper sulfate? Blue. Good. The copper sulfate color is blue. When you take the copper sulfate solution and dip the litmus paper or blue litmus, it will turn into red. Actually neutral, no effect, isn't it? But this salt solution turns into the affects the blue litmus paper and turns into red. That means this is slightly acidic, isn't it? The acid turns blue litmus to red. So copper sulfate is slightly acidic. When you take common salt, it is perfect neutral. What is the formula for common salt? Now only I asked. What is it? I told now only now, and sodium chloride. So it is neutral. So there is no effect on both the litmus papers. But when you take sodium carbonate, what is the color of sodium carbonate? White color. So it turns the red litmus to blue color. Means it is slightly basic in nature. So salts are not only neutral, some salts are acidic and some salts are basic. Let us learn in depth. Okay. So here some of them are acidic salts, some of them are basic salts, and some of them are neutral salts. Let us take normally acidic salts are formed by strong acid and a weak base, and basic salts are formed by strong base and a weak acid. Okay, you will learn what is the strength of an acid in the higher classes. Okay, now these acidic salts will release can easily release the hydrogen ions, and basic salts can easily releases OH minus ions. These are also you can learn in higher classes. Okay, just learn the names now. Okay, now here ammonium chloride, ammonium sulfate, sodium hydrogen carbonate, sodium dihydrogen phosphate, they are all acidic in nature. Okay, sodium acetate, calcium carbonate, sodium sulfide, potassium carbonate, they are in basic in nature, so basic salts. Perfect neutral are the sodium chloride, sodium sulfate, sodium nitrate, and magnesium sulfate. They are neutral salts. Okay, let us learn the next topic. So we'll learn some of the uses of acids, bases, and salts. You know, the 5 to 10% acetic acid is vinegar. Vinegar is used in the preparation of pickles. Okay, preservation of the pickles. This vinegar is used, and the citric acid is present in the lemons. So in the preparation of pulihora, citric acid is used. In the preparation of bombs or explosives, nitric acid is used. To remove the ink stains, oxalic acid is used. And in the batteries, car batteries or batteries, sulfuric acid is used. And in the medicine, lot of medicines and dyes, hydrochloric acid is used. And in your stomach is also dilute hydrochloric acid is present. Okay, used for digestion. Okay, and the bases, when you coming to the bases, it will remove some of the bases, will remove the greases. Okay, this ammonium hydroxide will remove the grease. And the soaps contains the bases of sodium hydroxide and potassium hydroxide is used to preparation of the bases, preparation of the soaps. Okay, in the preparation of soaps, these bases are used. And in the fire extinguishers, to control the fires, aluminum hydroxide is used. Okay, and some of the salts for you take in the preservation of food items, salt is used. Okay, in the pickles also preservation, salt is used. And then for washing the clothes, washing soda is a salt. Okay, in the cakes preparation, okay, baking soda is used. Okay, these are some of the uses of the acids, bases and salts. There are only is few. Okay, you have to remember all these uses very well. Okay, so just recollect what you have learned, a summary. Okay, in this whole lesson you have learned about the acids, bases, indicators, salts, and what are their properties, how do they behave. Okay, have you enjoyed this entire lesson? Okay, let us go for a funny one. Okay, it's a funny one. Okay, this enjoy this video. It's about neutralization. Okay, with a song. Normally you are very fond of the music, isn't it? Music, dance and something else. So learn by listening this video. Okay, and audio and video. Okay, enjoy.
Yeah. Okay. Arrhenius. What's a pH scale for solution whose an acid or base? Tell the levels of hydrogen ions present. Acids have more hydrogen ions, H plus concentration like a lemon. It tastes pretty sour, probably like a level 2 on the pH. Give it a test and it shows red on the litmus. 0 to 7 acidic hydrogen ion for liquid and then. And moving over to the blue litmus, it's a base but it tastes slippery fluid. Hydroxide ions, OH minus 6S like a product for your drain. Need an unclogging homie. Another name for a base, saccharides pH range from 8 to 14. High ions in a base type of hydroxide like toothpaste, soap, cleaning products like that. And when a base and acid mix and neutralize, H plus and OH minus combine, turn it into plain water. H2O plus on the side is a salt, for example sodium chloride.
So bases, mix them up with acids and what it makes is a salt and water, don't forget what the pH is. A measure of hydrogen ion concentration in an aqueous. Neutralize reaction, salt and water from acid and base. Neutralize reaction, neutralize reaction. Neutralize reaction, salt and water from acid and base. Neutralize reaction, neutralize reaction.
Have you enjoyed the acid base song? Very good. Have you learned, children? Have you learned? Very good. Thank you. Hope you learned well, very well, I think, isn't it? So, yeah, we are from Balaji English Medium High School, and I am from Science Department, isn't it? So, learn well and keep safe, stay at home, and learn well by taking the help of your parents also. And don't forget to subscribe my channel. Okay, children? Bye.